Welcome to Study Loop.
In this problem on the topic of waves and sound, we are told that a mixture of argon and neon gas, the speed of sound is given at a given temperature. If we assume that both monatomic gases behave as ideal gases, we want to find the percentage of the atoms in this gas that are argon and the percentage that is neon. So we know that the speed of sound in an ideal gas is given by V is equal to the square root of gamma kT over m, where gamma is the ratio of heat capacities at constant pressure to constant volume, K is the Boltzmann's constant, T is the temperature of the gas, and m is the mass of a single gas molecule. So the mass of a single molecule of this gas, m, if we rearrange, is gamma times K times T over V squared. And this is 1.67 for a monatomic ideal gas times K, which is 1.38 times 10 to the minus 23 joules per Kelvin, the Boltzmann's constant. The temperature of the gas is given as 3 times 10 to the power 2 Kelvin divided by the speed of sound in this gas squared, which is 363 meters per second squared. This gives us the mass of a single molecule of this gas to be 5.25 times 10 to the minus 26 kg, which we can write as 5.25 times 10 to the minus 23 grams. Now we need to determine the fraction of the gas that is argon and the fraction that is neon. So let's first find the mass of each molecule. Now the mass of argon is equal to the molar mass, 39.9 grams per mole, divided by Avogadro's number, which is 6.022 times 10 to the power 23, and that's per mole. And this gives us the mass of a single molecule of argon to be 6.63 times 10 to the minus 23 grams. The mass of neon, MnE, is equal to the molar mass of neon, 20.2 grams per mole, over Avogadro's number, 6.022 times 10 to the 23 molecules per mole, which gives us the mass of a single molecule of neon to be 3.35 times 10 to the minus 23 grams. Now we let the letter Q be the fraction of the gas that is in the form of argon. So Q is the fraction that is argon, and we'll label P the fraction of the gas that is neon. And now we know that Q plus P must equal to 1. And also Q times the mass of argon plus P times the mass of neon must equal the mass of one molecule of this gas. Now, if we substitute P to be 1 minus Q in this equation, we get Q times the mass of argon plus 1 minus Q into the mass of neon must equal the mass of our gas. So we can solve for the fraction as follows. We get Q, the fraction that is argon, to be the mass of our molecule, the molecule of our gas, m minus the mass of neon divided by the mass of argon minus the mass of neon. So if we suppress the units and we cancel the factor of 10 to the minus 23, we get 5.25 minus 3.35 divided by 6.63 minus 3.35. So this gives us the fraction of the gas, that is argon, to be 0.57 or 57%, which is argon. So from here we can find P, and hence the fraction of the gas, that is neon. And we know P is simply 1 minus Q, which is 1 minus 0.57, which is 0.43. So the remaining 43% of this gas is neon.